Okay, so for lecture number 3, I'm not going to have you do a ton of stuff with this, but I still want to introduce you to the concept. It's the concept of multiple regression. And in multiple regression, the purpose of multiple regression is to see if we might use a couple of predictor variables to account for a dependent variable. Can we use various predictor variables to account for a dependent variable? And the example I want to go over should be one that you are somewhat familiar with. It's the heart disease situation. So let's say that you're interested in studying heart disease and cholesterol, that you want to predict cholesterol levels. And in this particular situation, you want to see if the type A personality and family history might predict your cholesterol levels. So in this case, I have two predictor variables, the type A and the family history, and I want to see if these two variables might account for cholesterol levels. This is multiple regression because you have more than one predictor variable. So this situation, I've created a little example below, and if you look at the examples, cholesterol I measured with LDL in this example. I've got, 3, 4, 5, 6, 7, 8 people. And let's pretend for the sake of example, I also measured their type A score. A higher number would be more indicative of stronger type A. And you know what's supposed to happen here. If somebody is really strong type A, they should have more cholesterol levels or heart disease. And then I also measure their family history. Family meaning lots of parents with heart disease, a higher number meaning more of that. Notice once again, all these variables are continuous. So this would be a regression example. So first I show you the correlation matrix and take a look at things there. Look at the top line with cholesterol. Is cholesterol correlated with the type A score, the family history? Well, hopefully you would see that it is correlated with family history. You would write out for the R statement there, little r, and then in parentheses it would have 6 equals 0.987, and then you would write p less than 0.001, and you would say the more family history you have, the more cholesterol you have. That's statistically significant. For the type A score, hopefully you would see that it's not correlated. You would write out that R was 6 once again, because 8 minus 2 is 6, equals 0.260, and then you'd write p greater than 0.05, and you'd say cholesterol is not correlated with the type A personality. So hopefully that makes sense to you. The next thing is the regression. Now the type of regression that's most often used in this situation is called a stepwise regression. And in a stepwise regression, we have two predictor variables here. What stepwise regression will do is it'll put in one variable at a time only if it's significant. So it'll put one variable in, and if it's significant, then it'll try to add another variable, but it will only add significant variables in. And if you look at that top screen, it's basically telling you, and you would predict this on the basis of the correlation, that family history was entered. Family history was well correlated with things, so it put family history in because it looks like it is going to be significant. And when it put it in, if you go down to the second screen, it gives you an adjusted R squared of 0.969. So what does that tell you? The coefficient of determination. If you know family history, you can account for 97% of the variability of cholesterol. Now, is that good? Yeah, that's great. That really means that family history can predict things. And on the bottom screen, what does that tell you? The ANOVA screen says that amount is significant. F1, 6 equals 0.2 or equals 219, p less than 0.001, and you would basically say here that yes, in this case, that the family history can account for a significant amount of things. So hopefully that makes sense. If you go down to the next screen, the coefficients, it tells you that the family history, when it's entered alone, does account for things. The t-score is 14.8. If you square the t-score, it's going to be 128. And that means family history is significant and account for things there. And notice what it said it excluded. Type A is not. So that's just telling you that type A, the sig was 0.493. That is not a significant predictor. So hopefully this all makes sense to you and you understand this pretty well. Thank you. Bye-bye.